Hello everyone. Today we are going to see conformal mapping. Take two curves C1, C2 in Z plane. Those two curves meet at the point Z0 and the corresponding curves gamma and gamma 2 in the W plane intersect at W0 by the transformation W equal to f of Z. If the angle between the two curves in the Z plane is same as the angle between the curves in the W plane, both in magnitude and in direction, then the transformation W equal to f of Z is said to be conformal mapping. The other way of defining this conformal mapping is a transformation that preserves angle between every pair of curves through a point both in magnitude and in sense of rotation is said to be conformal at that point. Next we are going to see what is isogonal transformation. The transformation which preserves angle between every pair of curves in magnitude and not in direction, that is sense of rotation, is called an isogonal transformation. Next comes the theorem based on conformal mapping. If f of z is analytic and f dash of z not equal to 0 in the region R of the z plane, then the mapping performed by W equal to f of z is conformal at all the points in R. So this is an important theorem to understand that the derivative of f of z not equal to 0 implies the mapping is conformal. Next comes the definition called as critical point. The point at which the mapping W equal to f of z is not conformal. Those points are called as critical points. That is, f dash of z equal to 0 at any point, those points are called as critical points. For example, take W equal to sine z. So f of z we are taking it as sine z. Find the derivative of sine z, which is cos z. Then equate to 0 and find out what is z. So if you equate this cos z to 0, you will get z as cos inverse 0, z equal to cos inverse 0. So for what are the values, what are the angles? Cos becomes 0, it is plus or minus pi by 2, plus or minus 3 pi by 2, etc. So in general it can be written as 2n minus 1 into pi by 2, where n is an integer, which are all the critical points of the transformation W equal to sine z. So if we want to find the critical point, just find the derivative, equate to 0 and find the points which makes the derivative 0. Those points are called as critical points. Next, there are standard transformations called as translation, magnification and rotation, and inversion. These are the standard transformations we are going to study now. The translation is a transformation which is defined as z equal to z plus k, where k belongs to c. That is zw equal to z plus k, where k is a constant. So this mapping gives you a transformation of the image. Then next comes magnification and rotation. Here the transformation is w equal to k into z. So as k is real, you will be getting the magnified image. If k is imaginary, you will get a image with a rotation. Next is inversion. The mapping is defined as w equal to 1 by z. So we are going to see the transformations one by one with few examples. Consider the first example. We need to find a region of the W plane into which the rectangular region in the Z plane bounded by x equal to 0, y equal to 0, x equal to 1 and y equal to 2. This is the rectangular region. And we need to find what is the image of this under the transformation W equal to Z plus 2 minus I. This is the transformation is given. We need to find what is the image of the rectangular region defined here. So first we need to find what is the real and imaginary part of the analytic function. So first take w equal to z plus 2 minus I. Write w as u plus iv and z as x plus iy. Then separate the real and imaginary part in the right hand side. Equate that to the left hand side u plus iv. So you will get the real part u is equal to x plus 2 and the imaginary part v equal to y minus 1. Then after getting this, we need to substitute the rectangular region, edges of the rectangular region in this equation, and we need to find what is u and v. So if I substitute x is equal to 0 in this, I'll get u is equal to 2. Similarly, if I substitute y equal to 0 in v, I'll get v equal to minus 1. So likewise, I'll be getting the transformal boundary lines of the lines given in the problem. So for each and every x equal to 0, y equal to 0, x equal to 1, y equal to 2, I'm getting the images u equal to 2, v equal to minus 1, u equal to 3, v equal to minus 1. V is equal to 1 it is. So now we need to draw that and identify. Draw the rectangular region, given rectangular region in the z plane first. Take the coordinate axes as x and y. Y equal to 0 is x axis, x equal to 0 is y axis. X equal to 1 is a line parallel to y axis, and y equal to 2 is a line parallel to x axis. Then this rectangular region should be shaded like this, and then the image of this rectangular region is u equal to 2, u equal to 2, draw that u equal to 2 line which is parallel to v axis, then v equal to minus 1 parallel to u axis, likewise u equal to 3 and v is equal to 1. So we are getting a rectangular region here, and if you see the image, it is moved from the origin to somewhere else. It is according to the transformation given, the image has been moved. So the transformation given here is a translation. So we are getting the image which is moved from the position which is touching the origin. Now in the image it is moved to some other. Next we are going to see magnification and rotation. So the transformation W equal to AZ will give you magnification or rotation according to what is the value of A. So if A is real, you will get a magnified image. If A is imaginary, you will be getting it as rotation. If A is both real and complex together, it will give you rotated and magnified image. We will take the example and understand this transformation W equal to 2Z. So from this transformation, you can easily understand the coefficient of Z is 2, which is a real number. So we are going to get a 2 times magnified image. So let us see the example. The region R of the W plane into which the triangular region D enclosed by the lines x equal to 0, y equal to 0, x plus y equal to 3 is transformed under this transformation. So we need to find what is the image of the triangular region whose edges are given here under this transformation W equal to 2z. So W, you need to write it as u plus iv, z write it as x plus iy. Then separate real and imaginary part and identify what is u is 2x and v is 2y. Then we need what is u plus v also. So find u plus v, that will give you the relation x plus y. Then we need to find what is the image of x is equal to 0h. So if I substitute that here, I will get u is equal to 0. Then if you substitute y is equal to 0 in v, you will get v equal to 0. Then if you substitute x plus y equal to 3, you will get u plus v is equal to 3 into 2, 6. So now we need to draw these lines in the W plane so that we can get what is the image of the given triangular region. So we can easily understand the magnification. So see this, the image of u equal to 0, v equal to 0 and u plus v equal to 6. So u equal to 0 is v axis and v equal to 0 is u axis, and u plus v is equal to 6 is the intercept form of the straight line equation. So if you see this, you can easily understand that the image is magnified 2 times. So w equal to 2z is the transformation which gives magnification. So next we are going to see the next example where the transformation is w equal to e power I pi by 4. So e power I theta, it is of the form e power I theta. It shows that it is a complex number. So you can understand that this transformation will give you a rotation and the angle is pi by 4. Okay. So upon seeing the problem, you can understand this. So we need to find what is the image of the triangular region bounded by x equal to 0, y equal to 0, x plus y equal to 1. the same triangular region which we have discussed in the previous problem, but the transformation is e power I pi by 4 z. So now we need to find what is the real and imaginary part by rewriting what is this exponential term and what is z and what is w. So write w as u plus iv, z as x plus iy, and expand and rewrite this e power I pi by 4. So we already know e power I theta can be rewritten as cos theta plus I sin theta. Cos theta plus I sin theta. So therefore I can rewrite e power I pi by 4 as cos pi by 4 plus I sin pi by 4. Cos pi by 4 is 1 by root 2 plus I times sin pi by 4 is 1 by root 2 multiplied by x plus iy. So if you simplify this and separate the real and imaginary part, you will get the real part as x minus y by root 2, imaginary part as x plus y by root 2. So that you can easily equate this with u and v. So knowing what is u and v, now we can find what is the image of each and every edge of the triangular region. So when x is equal to 0, we need to find what is u and what is v. So u is minus y by root 2, v is plus y by root 2. So the relation between u and v is u is equal to minus v. Then when y is equal to 0, if you substitute here, you will get u as x by root 2, v as x by root 2. So both u and v are equal. So the relation between u and v is u equal to v. Then next we need to take this edge x plus y equal to 1. So if you substitute that x plus y equal to 1 here in v, you will get v is equal to 1 by root 2. Now we need to draw these edges in the w plane. So first we need to draw the given triangle in the z plane, x coordinate, y coordinate, x axis and y axis. Then y equal to 0 is x axis, x equal to 0 is y axis, x plus y is equal to 1 is a straight line whose intercept is at 1 on both the axes. So this is the triangular region given. Then a triangle given, then we need to find what is the image of this. So image of that is u equal to minus v, which is a straight line passing through the origin, negative orientation. U equal to v is a straight line passing through the origin, positive orientation. And v is equal to 1 by root 2 is a straight line which passes through the point 1 by root 2 on the v axis. So the triangle, if you see the image, it is a triangle but it is rotated through an angle pi by 4, because it is a straight line passing through the origin which makes the angle pi by 4 with the u axis. So easily you can understand that there is a rotation happens based upon this transformation. So the region in the z plane is mapped onto the region in the w plane, and the mapping gives you the triangle and it is rotated through an angle pi by 4. Hello everyone. Today we are going to see bilinear transformation. W equal to AZ plus B by CZ plus D, where A, B, C, D are complex constants and AD minus BC not equal to 0 is known as bilinear transformation. A transformation of this form is called as bilinear transformation, and this bilinear transformation is also called as Mobius transformation or linear fractional transformation. And the inverse of this transformation, bilinear transformation, is also a bilinear transformation. Next we are going to see fixed point or invariant points. The point is said to be a fixed point or invariant point if the image of the point is itself under any transformation. So if an image of a point z under the transformation w equal to f of z is itself, then the point is called as fixed point, otherwise called as invariant point of the transformation. Thus, the fixed point is given by z equal to f of z. For example, take w equal to z by z minus 2. We need to find what is the fixed point of this transformation. So image itself means we need to put w equal to z in that transformation. Then if you simplify this further, you will get it as z square minus 2z equal to z. And if you simplify this further, you will get 2 points from this step, which is z equal to 0 and z equal to 3. These 2 points are called as fixed points. So easily you can find the fixed points where the image of the transformation is itself. Next, we are going to see cross ratio. 4 points Z1, Z2, Z3, Z4 in the Z plane. Take 4 points in the Z plane. Then the ratio Z1 minus Z2 into Z3 minus Z4 divided by Z1 minus Z4 into Z3 minus Z2 is called the cross ratio of these points. So cross ratio is defined like this for 4 points in the Z plane. Next comes a property based upon this cross ratio. The property says that the cross ratio of 4 points is invariant under a bilinear transformation. So cross ratio of 4 points already defined. So that is given here as invariant. So what is meant by invariant? The images itself. So we are getting a result from this property, that is left hand side the cross ratio is written here in terms of W, right hand side cross ratio is written in terms of Z. So this is the property which is otherwise called as a 4-point formula of bilinear transformation. If you want to find the bilinear transformation, if the 4 points and their image is given, we can apply this to find the bilinear transformation. And next comes a note for 3 points are given in the Z plane and the image of those 3 points in the W plane is given. Then we can find the bilinear transformation using the cross ratio property. So the property easily can remember, it is W minus W1 into W2 minus W3. Numerator it is W, then suffix 1, 2, 3. Then denominator it is 1, 2, 3, then W. That is W1 minus W2 into W3 minus W. So whatever you have written in terms of W in the left hand side, similar to that, we are writing that in the right hand side in terms of Z. So it is Z minus Z1 into Z2 minus Z3 divided by Z minus Z1. It should be Z1 minus Z2 into Z3 minus Z. So for doing examples with 3 points, this note will be useful. So next we are going to see the example. Find the bilinear transformation which maps the points, 3 points given. One is 0, next is minus I, then is minus 1. Then into the image is given as I, 1 and 0. So first we need to write what are the given points. That is the given point, what is Z1? Z1 is 0, Z2 is minus I and Z3 is minus 1. Then similarly first point in W, W1 is I, W2 is 1, W3 is 0. Then we need to apply the cross ratio property for 3 points and we need to find the bilinear transformation. So just we need to write the cross ratio property W minus W1 then W2 minus W3 by W1 minus W2 into W3 minus W4. So it is W1, 2, 3, here denominator 1, 2, 3 W. Similarly in the right hand side. Then substitute what is W1, W2, W3 in the left hand side, what is Z1, Z2, Z3 in the right hand side. Then after substituting, we need to simplify further and we need to express the bilinear transformation as W equal to function of Z. We need to bring W's one side and all other terms to the other side and simplify further. So if you cross multiply, you will be getting terms like this and expand these terms fully. After expanding, collect the W terms in one side and all other terms in the right hand side. Then you will get W is equal to 1 plus Z by minus I into 1 minus Z. This is the required bilinear transformation. Next is an example shown to you. If infinity is one of the point in Z given or W given or both are given, how to find the bilinear transformation. So if any point is given as undefined infinity, first we need to simplify the cross ratio formula and get rid of that point from the cross ratio. Otherwise, we need to retain that point in the denominator so that if you substitute the point infinity, 1 by infinity, that term will become 0. So first the given points we are writing in terms of Z1, Z2, Z3, W1, W2, W3. So if you see, it's given Z1 infinity and W3 infinity. So take the cross ratio property to find the bilinear transformation. So after writing this cross ratio property, Whichever point is infinity, we need to take that point as common and simplify that with the denominator. See to that it is there in the denominator and others getting cancelled. So if you see the left hand side, W3 I need to take it as common. If you see the right hand side, Z1 I should take it as common. So that simplification is shown here. So W3 is taken common here, both in the numerator and denominator. So this will get cancelled here and remaining term is there in the denominator. Similarly, right hand side Z1 taken as common and that is cancelling with the denominator. Remaining, if you see, Z1 is there in the denominator. So if you substitute infinity, this term will become 0. Then further if you simplify, you will get the bilinear transformation W equal to minus 1 by Z. So if infinity comes, this simplification you need to do before substituting the values in the cross ratio property. Then easily you can understand how to simplify and get it. Then other problems are listed here for you to try later on. Thank you.